A Chinese research team has set out for the highest location in Antarctica, the Kunlun station, to carry out a 2-month inland expedition.
A sealed structure was detected deep under the ice, and moments later, the signal dropped. Antarctica is one of the most restricted and least explored places on Earth. But during a recent Chinese research operation, sensors detected a sealed structure buried deep beneath the ice. Initial data was transmitted, and then, without warning, communication with the site abruptly stopped. Today, we're examining what was reportedly discovered, what researchers believe the structure could be, and why the sudden silence raised international concern. Follow along for discoveries that push the boundaries of what we know about Earth. China's growing Antarctic footprint. China has been quietly building an empire on the world's most remote continent. Over the past 4 decades since joining the Antarctic Treaty in 1983, China has established 5 research stations across Antarctica. The most recent addition opened in February 2024. The Qinling Station sits on Inexpressible Island near the Ross Sea, a location that has raised eyebrows among Western intelligence communities. The station covers an area of 5,244 square meters and can house up to 80 people during summer months. What makes this location particularly interesting is its strategic position. The station forms a triangle with China's 2 other coastal bases, filling a major gap in their observational coverage of the continent. Satellite imagery analyzed by the Center for Strategic and International Studies shows rapid construction progress after years of delays caused by the pandemic. Chinese officials insist the station serves purely scientific purposes. They point to research goals in biological oceanography, glaciology, marine ecology, and atmospheric sciences. The station features advanced clean energy systems, including wind turbines designed to withstand winds exceeding 73 kilometers per hour, and solar panels that function in extreme cold. President Xi Jinping sent a congratulatory letter when the station became operational, calling it a platform for international scientific cooperation. But not everyone buys the peaceful narrative. The station includes plans for satellite ground stations and communication equipment that could theoretically serve dual purposes. Some Western experts suggest these facilities could monitor communications from Australia and New Zealand, both members of the Five Eyes Intelligence Alliance. The debate continues about whether China's Antarctic expansion represents legitimate scientific inquiry or something more calculated. The mysterious disappearance of RAN. In 2022, an international research team deployed an autonomous underwater vehicle named RAN beneath the Dotson ice shelf in West Antarctica. This robot submarine was designed to map the hidden underside of glaciers, exploring regions where no human could survive. The mission was led by Professor Anna Wallin from the University of Gothenburg, focusing on understanding how warm ocean water erodes ice shelves from below. RAN spent 27 days navigating the dark cavity beneath the ice shelf. The vehicle traveled over 1,000 kilometers, diving as deep as 17 kilometers into areas never before explored. Using advanced sonar technology, RAN created the most detailed maps ever produced of an ice shelf's underside. The data revealed complex patterns of melting, underwater currents, and structures that challenged everything scientists thought they knew about glacier dynamics. The team returned in 2024 to continue their research and observe changes to the ice shelf. This time, something went wrong. RAN descended beneath the Dotson ice shelf and never resurfaced at the planned meeting point. Communication with the vehicle ceased completely. The team suspects RAN either ran aground on underwater terrain or possibly became the target of curious seals investigating this strange intruder in their domain. The loss of RAN represents a significant setback for Antarctic exploration. These underwater vehicles cost millions to develop and deploy. More importantly, RAN carried years of specialized modifications to withstand the extreme conditions beneath Antarctic ice. Professor Wallin expressed both disappointment and determination, noting that they hope to replace RAN and continue this critical work. The silence from beneath the ice remains a reminder of how dangerous and unpredictable Antarctic research can be. Strange structures beneath the ice. What RAN discovered before going silent has scientists buzzing with excitement and confusion. The underwater vehicle revealed unusual teardrop-shaped structures on the underside of the ice shelf, some stretching up to 400 meters in length. These formations look nothing like what researchers expected to find. They appear sculpted by complex interactions between water currents, ice, and the rotation of the Earth itself. The structures resemble sand dunes or giant blue mussels frozen in ice. Their asymmetrical shapes suggest they formed under the influence of the Coriolis effect, the force caused by Earth's rotation that affects moving water in the southern hemisphere. Where water flows slowly, the ice base shows stacked ledges and terraces. In regions with faster currents, the surface becomes smoother with deep grooves carved by turbulent water mixing. Scientists also discovered massive pits and channels carved into the ice. Some of these cavities measure 164 feet deep and nearly 1,000 feet long. The patterns suggest that melting happens far faster in certain areas than in others. The western side of the Dotson ice shelf loses about 40 feet of ice thickness per year, while the eastern side remains relatively stable. This uneven melting creates structural weaknesses that could eventually lead to catastrophic collapse. Beyond the ice structures themselves, researchers found something even more surprising. Hidden ecosystems thrive in complete darkness beneath the ice. Swarms of tiny shrimp-like creatures called amphipods are darting through underground rivers. These discoveries prove that life exists in places scientists once considered too extreme to support any living organisms. The question now becomes, what else might be hidden in the unexplored 98% of Antarctica still locked beneath ice? Underground rivers and hidden ecosystems. In 2021, a different research team noticed an unusual groove in the Larsen ice shelf on Antarctica's eastern coast. Satellite images suggested a subsurface river flowing beneath the ice. The team drilled down through 1,640 feet of solid ice using powerful hot water hoses. What they found surprised everyone involved. The underground chamber wasn't just filled with water, but teeming with life. Swarms of amphipods filled the dark cavern. These tiny creatures somehow survive and thrive in an environment with no sunlight, extreme cold, and crushing pressure. The discovery had the research team jumping up and down with joy, according to Craig Stevens, a physical oceanographer involved in the expedition. Nobody expected to find a functioning ecosystem in such a hostile environment. The underground river showed unusual layering of alternating water currents that scientists still cannot fully explain. The discovery coincidentally happened during the massive eruption of the Hunga Tonga Hunga Ha'apai volcano in December 2021. Pressure waves from that eruption were detected in the sub-ice channel, demonstrating how connected Earth's systems truly are, even in the most isolated locations. This discovery represents just one piece of a larger puzzle. Scientists have long suspected that vast networks of rivers, lakes, and waterways exist beneath Antarctica's ice sheet. Until recently, these features remained poorly studied, and their potential to harbor life was unknown. Each new expedition reveals more about this hidden world, raising questions about what other secrets might be sealed beneath the ice. Ancient landscapes, frozen in time. Beneath East Antarctica's ice sheet lies a landscape that hasn't seen daylight in 34 million years. Using radar data and ice-penetrating technology, researchers identified massive blocks of elevated land buried under kilometers of ice. These formations cover approximately 12,000 square miles, an area roughly the size of Maryland. The landscape includes 3 huge plateaus and deep valleys nearly 25 miles wide and 3,900 feet deep. Professor Stuart Jameson from Durham University described the finding as opening a time capsule. The buried terrain was shaped by rivers flowing through valleys when Antarctica still had a temperate climate. The region likely supported vegetation before becoming sealed beneath ice. Unlike most glaciers that grind and flatten terrain as they move, the ice covering this area moves so slowly that the ancient landscape remains almost perfectly preserved. These fossilized landforms influence modern glacier behavior in unexpected ways. The ancient plateaus slow the advance of ice, unlike deep valleys that facilitate rapid flow. Understanding these effects becomes crucial for predicting how Antarctica's ice sheet will respond to warming temperatures. Some areas appear more stable than expected because of these buried structures, while other regions remain vulnerable to accelerated melting. The discovery highlights how much remains unknown about Antarctica. The continent contains enough ice to raise global sea levels by over 164 feet if it melted completely. Scientists need accurate models to predict future changes, and those models depend on understanding what lies beneath the ice. These ancient landscapes provide clues about how Antarctica transitioned from a green continent to a frozen wasteland, and potentially, what might happen as the planet warms again. Communication challenges in Antarctica. Operating in Antarctica presents communication challenges unlike anywhere else on Earth. Traditional radio signals struggle to penetrate the thick ice and cope with the continent's extreme weather conditions. Satellite connections provide the most reliable option, but even these systems face limitations. The harsh environment damages equipment, storms disrupt signals, and the sheer remoteness creates delays and complications. China's Zhongshan Station recently achieved a major breakthrough in Antarctic communications. In early 2025, the station established independent satellite network communication for the first time. Internet speeds jumped to nearly 100 megabits per second, equivalent to upgrading from 2G to 4G networks. Previously, the station's 80 to 100 researchers shared a mere 8 megabits per second connection that barely supported text-based web browsing. The improvement represents more than convenience. Better communications enable more sophisticated research, faster data transmission, and improved safety for personnel working in dangerous conditions. Real-time monitoring of experiments becomes possible. Researchers can consult with colleagues worldwide without waiting days for data uploads. Emergency situations can be handled more effectively with instant communication channels. However, improved communications also raise concerns among Western observers. Better satellite networks could theoretically support intelligence gathering or military applications. China has been developing its own GPS alternative called Beidou, and ground stations in Antarctica could enhance that system's accuracy. The dual-use nature of communication technology makes it difficult to separate legitimate scientific needs from potential strategic advantages. The Lost World, sealed in ice. Researchers discovered evidence of prehistoric life preserved beneath Antarctic ice. In 2020, scientists identified a massive soft-shell egg dating back approximately 68 million years. The fossil measures over 11 inches by 7 inches, making it one of the largest eggs ever discovered. Analysis suggests it came from a marine reptile exceeding 20 feet in length, possibly a mosasaur, ancient sea monsters that ruled the oceans during the age of dinosaurs. The discovery proves that Antarctica once hosted dramatically different conditions. The continent wasn't always frozen wasteland. Millions of years ago, Antarctica enjoyed warmer climates and supported diverse ecosystems. Marine reptiles swam in its waters. Vegetation covered its landscapes. The continent was part of the ancient supercontinent Gondwana, connected to Australia, South America, Africa, and India, before tectonic forces pulled them apart. Antarctica's bone-dry atmosphere has preserved countless artifacts from its warmer past. Fossilized remains of creatures like Elasmosaurus, a long-necked marine reptile, have been found frozen in ice. Each discovery adds pieces to the puzzle of Antarctica's ancient history. Scientists theorize that drilling into sealed landscapes could reveal ancient soil, organic material, and environmental clues about this lost world. The implications extend beyond paleontology. Understanding how Antarctica transitioned from green to white helps scientists model future climate changes. If the continent could transform so dramatically in the past, what does that mean for its future as global temperatures rise? The frozen time capsule beneath the ice holds answers to questions about Earth's climate history and potentially its future trajectory. The role of ocean currents. Warm ocean water poses a greater threat to Antarctic ice than air temperature. The circumpolar deep water, a warm salty current from the Southern Ocean, flows onto the continental shelf and attacks ice shelves from below. This underwater erosion happens invisibly, making it difficult to monitor and predict. The water temperature might only be a few degrees above freezing, but that's warm enough to cause significant melting over time. The data from RAN revealed how ocean currents create uneven melting patterns. The western side of Dotson Ice Shelf experiences rapid erosion where warm water concentrates. The eastern side remains relatively protected because colder water dominates that region. Where currents move slowly, melting creates stepped terraces in the ice base. Fast-flowing currents produce smooth surfaces with deep grooves carved by turbulent mixing. The teardrop-shaped structures discovered by RAN show how complex these interactions become. The Coriolis effect influences water movement, creating asymmetrical erosion patterns. Friction between water layers generates additional turbulence that accelerates melting. Small fractures in the ice concentrate warm water flow, turning tiny cracks into massive channels over time. These processes compound each other in ways that simple models struggle to capture. Understanding ocean current behavior beneath ice shelves helps improve predictions about future ice loss. Scientists need detailed knowledge of water temperature, flow speed, salinity, and turbulence patterns. Each ice shelf responds differently based on its unique geometry and the specific ocean conditions it encounters. The data gathered by vehicles like RAN provides crucial calibration points for computer models used to forecast climate change impacts. International cooperation and competition. The Antarctic Treaty created a unique model for international scientific cooperation. Countries that might otherwise view each other with suspicion work together in Antarctica, sharing data and resources. Research stations from different nations sit near each other, with personnel regularly visiting and collaborating. The treaty includes provisions for mutual inspections to verify that activities remain peaceful and scientific. China emphasizes its commitment to this cooperative spirit. Chinese officials point to joint research projects with American, Australian, European, and other Antarctic programs. The Qinling Station was designed to become a platform for international cooperation, according to President Xi Jinping's statements. Chinese scientists publish research in international journals and participate in global scientific conferences focused on polar research. Yet tensions simmer beneath the surface. Western countries question whether China's rapid Antarctic expansion serves purely scientific goals. The pattern of construction, the strategic locations chosen for stations, and the dual-use potential of communication equipment all raise suspicions. Some analysts view China's Antarctic activities as part of a broader strategy to position itself for future resource exploitation and geopolitical advantage. The United States and its allies have responded by increasing their own Antarctic presence. Military communications equipment gets tested at research stations. Satellite networks expand to provide better coverage. Inspections of foreign stations become more frequent and thorough. The delicate balance between cooperation and competition grows increasingly strained as more countries recognize Antarctica's strategic importance. What lies beneath unexplored regions? Despite decades of research, approximately 98% of Antarctica remains covered by ice, with its underlying landscape largely unknown. Modern technology has begun revealing what lies beneath, but vast areas remain completely unexplored. Each new expedition uncovers surprises that challenge existing assumptions about the continent. In 2022, scientists discovered an enormous aquifer of ancient seawater sealed beneath West Antarctica's Willan's ice stream. This fossil seawater probably sat trapped under ice for thousands of years. The aquifer shows a very salty base layer, overlain by fresh water, demonstrating complex interactions between ice, rock, and water. The discovery confirms suspicions that porous sediment beneath Antarctic ice bodies contains substantial water reserves. Ancient river systems crisscross the landscape beneath the ice. These channels formed when Antarctica enjoyed warmer climates, with flowing water carving valleys and transporting sediment. Some of these buried rivers might still contain water, creating pathways for liquid to flow beneath glaciers. Understanding this hidden hydrology helps explain how glaciers move and respond to warming temperatures. The possibility of even more dramatic discoveries remains. Could Antarctica harbor unknown geological formations? Might there be mineral deposits or fossil fuel reserves waiting to be found? Some researchers speculate about the potential for discovering evidence of past life forms unique to Antarctica, possibly microorganisms adapted to extreme conditions that survived in isolated pockets. The sealed world beneath the ice keeps its secrets closely guarded. The silence that followed communication failures in Antarctica aren't unusual, but they always create anxiety. When RAN went silent beneath the Dotson ice shelf, the research team knew something had gone wrong. The vehicle followed a pre-programmed route, designed to surface at a specific location after completing its mission. When RAN failed to appear at the rendezvous point, hours of uncertainty began. Autonomous underwater vehicles can't communicate in real time while beneath ice. Radio waves and GPS signals cannot penetrate hundreds of feet of solid ice. The vehicles rely on dead reckoning navigation, acoustic positioning, and sophisticated software to find their way. They surface at predetermined coordinates where researchers wait to recover them. When a vehicle doesn't surface, the team has no way to know what happened or where it might be. Several scenarios could explain RAN's disappearance. The vehicle might have encountered unexpected underwater terrain and become wedged in a crevice. Its navigation systems could have malfunctioned, causing it to surface in the wrong location under solid ice. Battery failure would leave it powerless and unable to move. Curious seals might have investigated this strange object in their domain, possibly damaging external sensors or causing navigation errors. The loss of RAN highlights the risks inherent in Antarctic research. Equipment failures cost years of work and millions in funding. More importantly, each lost vehicle means missed opportunities to gather critical data about climate change. The team hopes to replace RAN and continue exploring beneath the Dotson ice shelf, but rebuilding specialized equipment takes time and resources. Meanwhile, the ice continues melting, and scientists race against time to understand processes that will shape humanity's future. Discoveries beneath Antarctica's ice continue to raise unsettling questions, from how vast hidden ecosystems might be to whether complex life thrives in total darkness. While unusual ice shelf structures, geopolitical tensions surrounding China's presence, and the looming uncertainty of climate-driven ice collapse all point to a future that scientists are still racing to understand before irreversible changes unfold. Antarctica holds mysteries that challenge both science and geopolitics, from hidden ecosystems and ancient frozen landscapes to teardrop-shaped structures beneath ice shelves. While China's presence adds tension and the sudden silence of lost research vehicles like RAN reminds us how unpredictable the continent remains, yet the data already gathered hints at just how much more the frozen world has yet to reveal. What do you think is really happening in Antarctica? Share your thoughts in the comments below.